rumreiten. Also es gibt ja bei Kubernetes so eine schöne Security-Seite, die können wir uns ja mal angucken am Anfang.
And you need to switch to English because we already started.
Sorry.
So we have been discussing what we're going to talk about today as a quick peek, and today we'll meet for the 20th iteration of our coffee chat, or cafe. And since we've been trying to break Kubernetes security lately, we're now gonna look into more ways of making it more secure. And Kyverno is one of the things. The other one is encrypting etcd, but I don't want to spoil anything. I'm happy that Philip has prepared something for today, and just hand it over to you, Philip.
Yeah, hi. So welcome again. Just a small wrap up from last week. So we created our cluster again. So we have one control plane and two, let's say, worker nodes. We have the same namespaces like last time. We have our everyone can contribute namespace, and we have my workspace. And we have, again, we have two contexts. We have the admin context and the user, Philip, which has access to the Philip's workspace namespace with edit rights. So it's the default cluster role edit. And I have view permissions to the everyone can contribute namespace. So this is the same status like what we have created last week. So last week we let's say did some intrusion or some security views on the Kubernetes default setup when you create a kubeadm setup. So we could create privilege pods, and with this we could read secrets. We could gain access to SSH to the worker node. From there, with the CTL and the container runtime, we did some more effort to finally end up on the master or the control plane node. And there we had basically complete access to the whole cluster, and we could basically also took over the cluster. We renewed some certificates. We could change SSH keys, etc. So this was the status what we had from last week. This week we want to dive a little bit deeper in the security, how to secure the Kubernetes, and there you have a default recommendations which you have from Kubernetes and documentation. When we just take a look together here, you have the infrastructure security, cluster security, you have container and code security. On the infrastructure part, we have network access to the API. So this is not the part of today because this is external access to the API server. So with the cloud providers, you could manage this, but this is not part of our presentation today. What we will focus on is the API security, the access to etcd and the etcd encryption for this infrastructure section. And then we have some pod security policies in place. And then we also check some container security policies to check a little bit the best practices, what we can do on our own to secure the cluster, which we set up on our own. So there I want to start with the API server. Why did I prepare my comments a bit faster? Oops. Okay, so when we check the API server by default, also last week we talked about the execution command is a kube API server, and it started with some parameters. By default, this is a kubeadm setup, so it should be secure, but it could be that somebody configured some unsecure parameters. For example, the unsecure port is set to disabled, as we see with the 0. This is very good. We only use the secure port with HTTPS. No plain text is enabled, and also no local setup. We can also see this here on the API server, local host port with the insecure port flag. We could also add some insecure bind address and some more parameters. And what you really want to check for is the anonymous of true. If this is enabled, you could basically curl the API server and get some information about the cluster without authentication. The insecure port, when it's set to somebody, so default would be 8080. If you set it to 0, then it would be disabled, so no local access to the API server. And you have the Kubernetes service node port, which basically would expose the API service on every node as a node port, which could be also a security threat or security, what's the word? Oh my God, sorry. Security exposure. So this you also want to check if it's not there. So on our cluster again, what is default kubeadm setup? We can see that we don't have any of this flag set except this one, but this is with 0 is disabled. So on the API server, we are good to go. Also on the cloud providers, they also have the same recommendations on the API server, but if you have a managed Kubernetes, then they will do it for you. But it's good to know and to check and maybe go for it and dig a little bit deeper in the API server. What we want to do now is, if you remember last week, we connected to etcd and could read secrets in plain text. For this, we can do it again. We're just creating a secret again. Sorry. So we create a secret and everyone can contribute namespace. It's a generic secret and we call it plain text secret. And then we set it password as plain text. Okay, and then we go again to our etcd pod. And then etcd. Oops, sorry. And then we execute our prepared command, which we will share later. And we see we created the plain text secret, and we again could see it in plain text. What we want to do now is encrypt the etcd, that you don't have this available. There you have a nice workflow from Kubernetes, where you can see you will give the API server basically encryption configuration. It's a YAML file which you will place on the master node, and here you can give some parameters. This is explained here. The important thing here, what is very important is, if you have a running cluster, and this is not new, you have the identity provider, which is this one. And this is basically the provider for plain text. What Kubernetes will do is, the encryption configuration is used in batch mode. So it will go there and check what's the first provider. If it's identity, it will store basically the secret in plain text, and so on. Yeah, so what you want to do is basically in this example, you want to do the encryption configuration before and then the identity provider after. And this is also important because you need the identity provider there for reading the secret. The order doesn't matter, but you need the identity provider in the configuration in order to read plain text secrets. And this is needed for, you can re-encrypt all the secrets, but you will have to read them. Yeah. That's what we basically going to do. So for this purpose, we go on we exit our session. We will get the IP from our master node. If you have some questions or something's unclear, then please feel free to interrupt me and scream. Okay, and then we go to our default Kubernetes directory. What we do here now, what we want to do here is create a new directory. I just call it, I don't know, API. And then I create a new file, let's say encryption.yaml. And here we just go here and just use this config. There are some providers available, for example, AS, CBC is here. You can see the strength is the strongest, speed is fast, key length is this. You can decide what you want to use, but I think secure box is a new standard here, but let's go with this one. It's the recommended choice for encryption on the rest. Yeah. So sorry, we will just copy the configuration here. Okay. And then there's a workflow. So we just create a generate a random base64 secret. There we have it. And then we will copy it in our configuration. Oops. Okay. Now we have the file. And what we want to do now is, as we created a new directory. So the kube AP server will not know about, or it's not there. So we have to go to the manifest folder, manifest. I'm there. So I will go. Okay, this is there. Okay. Check the Vim API server. And as you see on the kube AP server, you have in the bottom of the file, you have some volume mounted. So we have the folder etc as a cert mounted, CA cert, Kubernetes PKI. And what we want to do is to mount our directory. But I did a little bit mistake because I used the wrong folder. So I will just move my API server folder to etc Kubernetes. What doesn't it do recursive? Okay. What's the command there? Oh my God. I will just do it now. Sorry. Kubernetes API. Then I will move my file from API to, let's say, Kubernetes API. Is there nothing in there? What I did? Ah, okay, I got it. Sorry.
I think you just need to move the encryption YAML, right?
I did not. Yes, I did not create it in
no,
the directory what I wanted.
we all make mistakes.
Okay. And so again, we are here. I copied it. Okay, perfect. So I removed the API. Yeah, sorry, you think like this, and then I remove my encryption configuration. Okay, now we're good. So I will check here. Okay, so I created a file with some. I think I created a folder here. Today, etc Kubernetes API, and here I placed my configuration. Finally, after some workarounds. So what we want to do now again is go to the manifest folder. So we manifest and then update the API server configuration. This is a static pod. And what we just do is we take, for example, this as example here, the host path. We copy it, and then we basically just insert our configuration. Then we just use the API folder, and we call it API. Okay, so we're mounting our new directory into the pod, and then we have to. This is the volume, and now we have to create the mount inside Kubernetes. There we go again here. Oops, what did I make a mistake? Okay. So we created in read-only mode, so the pod cannot modify it, but can read it. And there we are. Okay. So this is done. And now we have to go here and see there is a parameter for the API server. This is the encryption provider config. We will pass the argument to the API server. So again, go here. And I'll just put it here. And then we will use etc Kubernetes API, then encryption.yaml. I hope this is right now. Let's see the API server. Encryption.yaml looks good. Okay, then we restart the API server. This we can do. We can use the commands. We just can move the file out the folder and move it back in again, like we did the last time. So we move the API server to root, and we will move it back in. Okay. Keep the puts. Hope we did not mistake. Okay. Never will work when you do it live. etc Kubernetes API encryption YAML with a config is good. Our volume is etc Kubernetes API. And the host path is etc Kubernetes API. Looks good, huh? We have no local access never changed.
Can we kind of access logs somehow?
Yes. I could also do it. Yeah, okay. Then yes, we could create pods.
Because likely there is either like an indent is wrong or the YAML. Maybe we can also like lint the YAML file.
Yes. Do we have a linter inside? No, but we can use it. We can use cube file thing. Okay. We could. There's a. But there's a.
Is there a way to load the configuration, but only do a dry run and like do a verification?
No creCTL config. So creCTL. 1 second. We just have to.
If it's easier to just check the logs, just do that. I'm just thinking out loud what I would use for debugging.
Yes, we could use YAML linter for sure, but this would not tell us about the typo in the path or something. So I just want to recheck my 1 second.
Maybe it's a permission problem.
No, this is okay. This is a privileged pod. So it's started by the kubelet, and the kubelet has enough rights. I think it's a typo somewhere. So Kubernetes API, and then I have encryption.yaml. I'll just give me 1 sec. I did it 5 times before. Just 1 second. We'll fix it. I think. Config it. etc Kubernetes API. This is good. Okay. Just check. Okay. So volume mount etc Kubernetes API, Kate's API, read only true. Okay. Kate's API. Okay. This looks good. Okay. Then we could have also check again the API, the encryption configuration. And then if you check this, secrets, key1, then just check again if you created the right on the folder. If not, we have to go to the logs as Michi is mentioned. Okay. The key we also created right. So, okay. So I have now have to increase the config for creCTL config.
Or maybe stop the daemon and run it in foreground.
Yeah, but I have to put my creCTL config here because it's not prepared for container D. So we create a creCTL file and then we just paste this command here for Unix. Then we update the sockets to container D, and then we will see some container D logs like last time. So it's not planned that it's not working.
It's always the case, but I'm curious what you're doing now.
So I used container D as the container runtime here, and creCTL is the command line tool. This one does not know that we are running container D, so I have to give the config to creCTL.
Ah, okay.
Yes, you can create a config file, etc creCTL, and then you just paste the, you give them the container D runtime and the container runtime socket, and then you can use the creCTL like we used last time. Here we are.
Yeah, and if you want to use a more compatible API, you can use nerdctl. So there's also from
Okay.
So it's like the Docker CTL, so it's like more intuitive probably for new users. Because the main stuff behind it is that Docker uses also containerd, and Docker is only proxying commands directly to containerd or manages containerd instances on the machine. That's the difference.
So probably then the next session should be about debugging Kubernetes.
Yes. But did not start any pod. That's interesting. I will move it out again.
Maybe there is a pod binding collision. No. Can you?
Right. Oops. Yeah. Oh my god.
Okay, the pod is not reachable, so it's either not opened or nothing is listening on that pod. Okay, yeah. How about the logs?
Yeah. 1 second. This one doesn't start the. Okay.
You can also use less-shift F, which brings into a search less dash the big F, a capitalized F.
Okay.
And then the log file. So you like get into less, but it updates itself. It's a better way of having a tail log file. Maybe messages, or is there
pods, cube system, cube controller, etcd. Why there's no AP server logs? Nowhere. Okay. It's really interesting. Okay,
nothing is started, so the pod is not there.
But why? Okay, service. Oh, sorry, service. Qubit restart.
Maybe the restart was missing.
Yeah, but normally it should be enough to. So my preparations, it worked 5 times with moving out the file. Let's see.
Maybe it's the Windows case. Reboot is good.
Or
like the German one.
Send a CCAP, so it could be also okay. So the process knows when to read out the configuration.
Cube API server.
Is the IP address in the pod correctly? So if we
take out the configuration.
50.
What I did. Okay. Yeah. So we did a cluster session. We break our cluster and
it's spontaneous. It's authentic. So we should get it fixed in 1 hour.
Yeah, but it was not, like I said, it was not planned.
Okay, it was not refused.
Okay. So
Nmap is okay. No, Nmap doesn't. Nmap doesn't help us. It only shows open ports. Is the port correctly?
Yeah, but we did not modify it. We just created this one here, encryption YAML, and we added the volume mount. This could be one thing, but I'm wondering why there's absolutely no pods. It doesn't even start a pod. This is what I'm wondering. Should be like something like at least failed.
Here we start Kubernetes. Where are the logs for that? Or where is the action log for that?
This is a good question. This should be oops. No. Should be in the syslog. Node, Kate's server not found. Mhm.
What was the failed?
Maybe to register node. Oh.
This is the
Finish
so
to
fast.
release.
We'll try.
Okay, I cannot reach the. But
okay, the API server itself is broken.
Why does it say? How? Okay. Then we just make just check it again our file. So we removed our host path. What we did, we created this one. Okay. We did a YAML. Yeah. So YAML lint would help us. You're right.
Yeah, maybe the Kube API server has some flags to validate something.
This I really don't know, but again, I think now it should be working. So I did a YAML space issue, created it. And we have to make a bigger section on debugging. Kubernetes API encryption.yaml.
I know probably the problem with the reload. Are you using Vim, right?
Yes.
And Vim creates a temporary file, not directly on the file itself. So when you write it afterwards, probably the inotify on Linux won't be triggered, so that the kubelet knows the change. So probably if you open it with nano or something like that and do there the change, it should be automatically the reload.
Okay.
So it should be related to inotify.
Okay. The thing is, I also my preparation, I did not use Vim. I used VI. Because I just
VI is the same.
this.
VI and Vim is the same. So
okay.
The plan behind it. So
okay, I'll give it one more try.
But maybe it's also a spacing issue. The thing I'm wondering is
there he is. Okay, we're back online. Now we see it. Not ready. Interesting. Okay. Happens. Good. Come on. Yeah, we're back online. Perfect.
But what
just
was
leave the server.
Now?
We just in the host mount. So we're mounting the volume to the folder to the pod, and then we create a mount, the volume mount, and I did a space issue there. So I added the trailing white space. Yeah. So your first idea to make a YAML lint would help us a lot.
There's also
but there's a good learning. There's a good learning. Never go manual on the server and modify some files. Basically, only use it automated in your CI.
The thing is, you can. I need to look up my Vim RC. There is a way to highlight trailing white spaces or wrong white spaces.
Yeah, I know. But basically, I thought just go on the server, edit the file, restart the API server, and then leave it would be enough for us. But yeah, the live session. Okay. So what we did now, we encrypted after some circumstances, we encrypted finally our configuration. What we do now is back on track. We create a new secret. Okay. We call it again, and everyone can contribute namespace. We call it encrypted secret, and the password is encrypted in some capital and small letters. So we create it. Then we go back on our etcd pod and then try to read it. This time we use the shell. Then I prepared the command. Hopefully, this is the wrong. This one here. What we see now, it looks like this. Yeah. So this secret now was created encrypted, and if nobody has the key, we are not completely safe, but we are safer. let's say. Here's the old one, which you can still read. Yeah. And then there's also a good thing from Kubernetes or from the documentation. You will see here a small little command on the section verifying that your data is encrypted. You can recreate it and read it. And then we have to ensure our secrets are encrypted. So we just run this command here as administrator for sure. Oops. If we use the copy command, right? Okay, this replaces all our, so what does it basically do? I can show the command in the meantime. It gets our secret, puts it out, makes it an output JSON, and then just replacing the existing secrets with the new generated ones. And then as we enable the encryption configuration on the API server, we'll have all the secrets encrypted in the etcd server. So there we go again on the etcd server or pod, whatever you want to call it. And then we take our first secret, the plain text secret, again. Let's see, it's now encrypted. So basically, we secured the API server now. We secured the API server was secure, and we just verified that it's secure. We encrypted the etcd, and also soon we will limit the access to etcd. Or this you can do also better with RBIC, like Niklas told us. So basically, you want no user that they have access to the kube system namespace in your multi-tenancy cluster. And then we can go on checking this thing here, the components in the cluster. So RBIC authorization, we discussed it, and Niklas presented it. The authentication part we will do later, maybe with OpenID. And what you now have is network policies, quality of service, TLS for ingress. So this we covered, I think, by Max. The network policy is a little bit more advanced topic, which you can tackle in our own session. And we can discuss now the pod security policies. And there we have this this tool or this software called Kyverno, which basically is the admission controller. When we looking at Kubernetes, give me 1 sec. There was a nice picture. No, this is not. So what is the admission controller? So Niklas talked a little bit about it. When you do an API request, this is handled by the API server. It's a web server, and at the end, it will be persisted to etcd. What we basically do is the authentication authorization part. This is the RBAC. And then we have the admission control. Admission control intercepts the request before they are written to the etcd server or before they are persisted. And you can validate the request. You can mutate them. You can generate them. But the most way of using it is mutating and validating the admission. So basically, for example, you will send a request to API server to create a namespace, and you can do a validating admission to check if the namespace has some labels, because you will need labels later for network policy. So you want your namespace is labeled. Or you can add a mutating admission. You create the namespace, and your policy or your mutating admission controller adds a label to the namespace. So these are the basic use cases. And for this, you can use Kyverno. When you look at the introduction about Kyverno, or Kyverno, I don't know how it's spelled. So it's basically, it's an admission controller, which validates, mutate, or generate resources. It intercepts all the API commands we will send to etcd, and create or validate it, or with this thing. So what we can do is to just install it with a small command, and there we don't do it on the etcd server for sure. We will just exit it. Okay, and then we can just a little bit explore it now. What it did, it added some custom resource definitions. Custom resource definitions are here. A small overview is there are extensions of the API. So we will have now, with this custom resource definitions, we will have some new commands available in etcd, on the Kubernetes cluster, sorry. For example, we will have kubectl Good. Then we have. Okay. Fourth effect. Today is really running good. What was the comment? Yeah, I'll just get it here. For example, we have this now. Cluster policy. So yeah. No resources found, and then you can also do policies. No resources found because we did not create anything. So these are basically custom resource definitions. We have new commands available in Kubernetes. What it also did here, it created. Yeah, sorry.
Yeah, short question. What are the policy reports? What are they doing?
The reports.
Yeah.
We'll come later to it.
Okay.
We'll make a small showcase. Wait, I will show you.
Yeah,
You can maybe save your question for later. It created a server account. It created some RBSC roles and permissions, some cluster role bindings. It created the config map. It created the service. Yeah, what we basically can check because the Kyverno system works like this: that your policies will be checked in the background. Okay. 1 second. Give me 1 second. I have to close the baby phone. Sorry, 1 second. Okay, I'm back. So I can hear my wife talking with my girl. Everything. So it's a little bit annoying now in the session. But what Kyverno will do, there are two ways of working with policies. You have an enforced mode and you have an audit mode. Okay. This we can see here with introduction, background scans. You have an enforced mode and the audit mode, and a background check, background false or background true. Kyverno validates in the background your policies. Okay. And this will be done, like discussed here, every 15 minutes. And you can also see here when your audit is, for example, you have a running cluster, you will test the policies, you create new policies, you do the audit mode, and then you will see a report, how many pods are matching a policy, are they failed, are they passed? So you can test new policies and basically check what will happen in your cluster. Yeah, and then you can do report on it, can check it, and so on. So, and then in the background, every 15 minutes, it's running, and yeah, we'll make the report. Then the enforced mode, for example, as you see here, when you have a new resource created and you have the enforced mode with background true, you will see non-report because enforced means it's forced. And for example, if I don't allow you to run a pod with privileged and I make it enforced, it just blocks the pod and then you cannot run it, but there will be also no report for you available. So you do not see how many agents or how many users are doing this. Okay. So that's the difference. And you can have a nice table. So basically when you do the enforce, you will have non-report on this one, except they are existing. When I have a pod running existing with a privileged mode true. So this will report it as a failure on the policy report. This we can see later. What we want to do now.
Quick question. Can you share me the doc URL in the chat?
Yes. Now, okay, wait. Where's the chat? Here.
Yeah, Discord or Zoom chat. Doesn't matter. Just so we can follow along.
Yes. Okay.
Thank you.
Okay. So what we basically maybe want to do first is I created some default policies, which we can take a look later. And we just apply them now, then see later the outcome. So then we can explore a little bit because it's running in the background. Okay. And then we can create some new pods and so on. So what we do, we disallow some host namespace, privileged containers and privileged containers. We disallow or we don't want secrets from environment variables. We require some namespace labels. We restrict auto mount of service account token. And we restrict some image registries. Yeah? These are some default policies. You also have a good documentation here on the policies. And then you have pod security, default, restricted, so heavily restricted policies for your cluster, minimal, best practices, what you want. So there are a lot of examples. So I just took some for our purpose this week. So basically, yeah, then we have a config map. This is really important. So we just go there. So okay, it's in, I think, in the Kyverno namespace. Get config map, init config, make it output with YAML. And what we see here is that there are some exclude roles and excluded, for example, namespaces. So the kube system namespace, for example, is excluded. So you can exclude some namespaces if you want, or replica sets are excluded, maybe because I know you normally create deployments and daemon sets. The policy in the cluster report things are excluded. So you can exclude your namespace if you want, but kube system, yeah, it's a good way to exclude it, because, for example, if you would need to run privileged pod in your kube system, for example, the network plugin, the CNI, which you're running, for example, Cilium or Calico or Flannel, they will run privileged pods to enable network for your cluster. So you definitely don't want to block them. That's why they are excluded here. But this, you just have to keep in mind that kube system is excluded. That's why you basically also don't want to give anybody access there except the real cluster admins. Okay, then we can go on. Then we have a service here, where this is basically the admission controller, where the validation and the mutating, generating things will happen. This is called every time. So then we can also we can explore a little bit. You have a mutating webhooks configuration, policy mutating, resource mutating, verify mutating. Then you have some validating webhook configurations. Basically, you can check here the configuration. I don't want to dig that deep in these things. We can go here now and see our cluster policies, and there we see background true for everything. So every 15 minutes, this will be validated, and we have the action here. So we will enforce disallow host namespaces, the privileged things, and the namespace labels. This we definitely want to enforce, and we audit or monitor some other policies. And then we will have the thing Niklas wanted, the policy report. The thing on Kyverno is that the policies are generated, the report is not on policy, it's on namespace. So the namespace, everyone can contribute, have this policy report. So Polar is the short abbreviation. So you could also use it here. Polar, Polar. And then you have the report here. So 14 of our configuration items passed and 4 failed. And in the other namespace, it's even worse. So 10 failed. Okay, so we can now audit this or check what's happening there. In my namespace, for example, there we have a comment. We can make the describe policy report in the namespace, and then we just grab the status failed. And then we have a nice overview, or not nice overview, but we have an overview. For example, in the pod showcase 1, we have a rule privileged containers failed. We have the validation unknown image registry. So I use the registry, which is not trusted by us, our cluster, and so on. These are some things you can do here. And if you want to dive deeper in something, then just tell me. Yeah. And then we have also the cluster policy report. So this is for objects which are not namespaced, like namespaces. Cluster objects which are not namespaced, they are in the cluster policy report. Everything else what is namespaced, for example, like daemon sets, deployments, pods, will be in the policy report section. Yeah, so you can also see here, there are some failed. Let's see why. We have the validation error. The label cafe/number is required for a namespace. So we did not add cafe number 20 here. So this is a validation of our error of our namespaces. Yeah. So I think everyone who's worked with Kubernetes should know that you should also label namespaces. because later on you will definitely need it. Basically, you need to label everything and have a good label concept in Kubernetes. If anyone wants to see something deeper or more, then just tell me. Yeah.
I have a question to that. So
Yes.
would it also be possible to get reporting or auditing of my cluster issues, or not cluster issues, of my cluster roles and cluster role bindings? Would I also see that in the cluster policy report when I give someone in a cluster role too many access?
Mm-hmm. I think you could write a policy for this, and you should see it then on the cluster policy report.
Okay.
I think the thing is here, we can also look at one policy. For example, this one. This is the layout of the policy. And what you see here, it's like the big pro argument of Kyverno is it's like cloud native integrated. So you just use your YAML files, you can write it, you don't have to learn a new language. Yeah. So you have your kind resources. And I think you could also match your cluster policies, but we can test it. I don't know if you want. Yeah, and then you have some. Yeah, if you can check it, then send me.
The simple case would be, hey, I want to see who is everyone violating the cluster admin or sysadmin.
Mm-hmm. The thing is, but the thing is, there should be a validation. You know, there must be. I think it must be more like is Niklas or is somebody else except Niklas cluster admin. I think this should be the rule here in this case.
Mm-hmm. What's the most common attack vector? So like what we tried last week, getting into. Yes. Is there a
definitely
common use case or say, I have no idea.
Yes.
Or maybe the forbidding the mount.
Yes, you could do a lot. For example, here we have a policy, the privilege escalation. We if must be false, so it's not false, then you will get an exception. We can also try it soon. We have privileged containers, so the privileged is not false. Then you will get an error. We have this disallow secrets from environment variables. But I would not. Maybe I don't know. You can just audit it and later enforce it. Then the namespace labels, for example, here we can add also several labels here. The kind is just a namespace. Then we have the auto-mount token. Yeah.
The thought I had is last week we kind of mounted a file system and injected the SSH keys and like authorized ourselves. And can we like practice this now and say, hey, we want to do this again, but now we have the policy which prevents us?
Yes, sure. So then again, I just want to show the policies that it's YAML based and you don't have to learn a new language. So if you use the open policy agent, you have to learn this Rego language, it's called. And I mean, as we discussed also last week, you have much more use, or you can use OPA maybe everywhere. You can use it in your CI. But if you want your cluster more secure with one click and don't want to learn a new language, write some YAML thing, then Kyverno is definitely good. And it's also really extendable. So I really like it for now. What we can do now, last week I shared this repository. We'll add it again here. So we have this bad pods repository on GitHub. I will share it also later. There you have some examples. And what we again had is not the policies. We will want to get my policies. Yes. So policy report. Oh no, sorry. Wrong. Cluster policies. And here we see host namespaces is enforced again, privilege escalation enforced, privilege containers enforced, namespace labels enforced. Okay. So what I can do now is go back to the repository here. And then there are some commands. I just run them from GitHub now, but normally I would not do it, but it's our test cluster. And then we have, for example, everything allowed except pod. Yeah, seems like a pod which should not run on our cluster. And what I do now is here as administrator, I try to run this pod, and then I have this error here from the validate Kyverno. So that's the validation webhook, which we configured. So it validates if some things configured in the manifest file, which should not be. What we, for example, have disallow host namespaces. So sharing the host namespace is disallowed. So you could also, with the host IP, for example, you could also take over root rights on the host where the container is running. And we have the same here with privileged pods or privileged containers. Privileged mode is not allowed. So basically, we could not run the pod now here. We have the same with, for example, just privileged exec pod. There's another pod which we just try to run here with the same issue here. Privileged containers, it could not run. Yeah. Do we have more? What do we have still? We could just run a basic pod because we disallowed do we enforce it or audit it? Sorry, oops, wrong comment. So the Automount SA token, we could run a new pod now, but then we have to wait 50 minutes for sure now. We could force it. So we just edit the policy. Then edit cluster. Okay, so we edit and we just set the validation to enforced. Enforce. Okay, and what we now did is we're enforcing that nobody can run a pod where you have an auto-mounted service account token, which is basically default. And when we run test mount and the image is Nginx, it should basically not run, and it does not run. It's an auto-mounting of service account tokens is not allowed. So you have to create a YAML file now, and then you have to set service auto-mount token false, and then basically there you have the security back. What we also have is image registries, for example. We can also take a look at this manifest file, image registries. For example, this rule here, this allows all images which are not from Kubernetes Google Container Registry or directly Google Container Registry. So this is like an OR, so you could add yours here. And when I now try to, for example, we have to also edit it and enforce it, because otherwise we will have to wait a little bit to see our results because of the 15 minutes thing. We can also go here, and we go to, again, to enforce. Enforce. There was a problem with V. It didn't be saved. No.
So this essentially means that I'm only allowed to use a specific container registry in my DMZ, for example, and not just like Docker Hub, which is maybe rate limited, or like any other one.
Yes, exactly. For example, here.
This is the first one I would totally install.
Yes. So basically here we run a container or a pod, which is called unsecure registry, and we use the Nginx, but from the Red Hat quai.io.registry. And again, we have two errors here, the validation. We have the auto-mounted service account, and we have the unknown registry, which not matches our policy. Yeah, and because also what I showed last time, because let's say the reporting of the policies is not that good right now in Kyverno. The guy called Frank Jogeleit is also contributor of the month at Falco project. He wrote the small policy reporter for Grafana and Loki, or Prometheus and Loki and Grafana. And then you have a better reporting. For example, in the screenshot, you can see here the policy check label app, the rule on the namespaces, you can have a little bit more or better overview of your policy failures. But I did not have the time to install it in the cluster this week. Yeah, but I talked yesterday with him, and he is on version 0.50 now. He soon will release the 0.1 final release because he's satisfied. And I think it's also a good tool if you really use a lot Kyverno in your cluster. So if you want to do, maybe we can, if we are later, automate our cluster more and implement monitoring, what Michi always wanted. To have an auto cluster with monitoring, we can integrate this policy reporter also with Kyverno. Because I think, yeah, as pod security policies are deprecated, you should use Open Policy Agent or Kyverno, at least in the cluster, to have it secure. Yeah, basically, if you want to see some more on Kyverno, I can show more. Otherwise, I think I would be finished for my showcases.
So, thanks. I have crazy ideas oftentimes. I was wondering if we had any other use case from the break-in session last week, which we did not cover yet. So the auto mount is fixed. Privilege escalation is also fixed. Containers is something we did not touch yet. What else did we do last week?
So we can go again, hop to my user. Yeah. So, okay, get NS. Oops. Get NS namespace. So I can't get namespaces. So cube. Okay, run Philip image engine X. So I can't do anything here. So I can't create even a normal pod. So we had this when you have the service account mount. It's a token basically in the pod. And what you could do if somebody, for example, what we said last week, if somebody edited the default service account and give them more roles for testing purposes and they forget it to revert it, because this sometimes happen when you do manual things, then you could use this token to curl the API server. So this we prevent it because we don't want the default service account mounted. Then we had the use case. Basically, the most use case is when you get root rights on the host node. This is via host PID or via privileged pods. Yeah, this we also have here in the first thing what we had in a good overview of the security. Yeah, so this infrastructure we handled, cluster we handled with the pod security policies. Then you have the container. So this allows privileged users. You could also run more. You can also, in the best practices here, default, or let's say restricted, there's some more. You can require run as non-root. So yeah, the PID of the process running in the container should not be root, for example. Then deny privilege escalation, restrict volume types. For example, nobody should run host mounts. There's a lot of things you can restrict, but basically the most concern is the privileged pods. And what you also want to do for sure is don't run vulnerable containers on your cluster. Sometimes you cannot prevent it, but you definitely want to implement some vulnerability scanning of the containers you run. But this can be done easily in the CI with Trivy, what we discussed. So this also maybe need a session. And then, yeah, you have the code security, which is also not part of our showcases. So I think we did a really good progress with our cluster. If somebody else has something in mind, please share it. So you could for sure network policies, but it's like really not advanced, but it's a topic where you have to really know what's in your cluster and which pods connecting from where. So you could basically restrict pod from namespace 1 to connect to the other pod in namespace 2. This is the network policies.
So this is a crazy thought. Is there a way to measure runtime data? So like network traffic or something else, CPU usage, and use that data to define a policy? So like receiving metrics from Prometheus or the alert manager actually, triggering a threshold, and then the policy kicks in and prevents something bad from happening?
For sure, you can do metrics. Yeah, so the default metrics in Kubernetes, if I'm not wrong, are CPU and RAM. So you don't have more default metrics. So you need to program, but easily you can do as we did last week, but you have to set it up more secure. You can use a API connection from inside a server, or like a Python program, I don't know, which calls the API server and patches the deployment, patches policies, creates some things. It's definitely a use case. Because I think if you use autoscaler in the default Kubernetes setup, you cannot really work with RAM and CPU, because when your RAM or your CPU is full, then it's too late. You definitely want to scale up before. So that's why you have to work around and maybe curl the API before, or curl your application, something like this.
So mostly
to answer your question, yes.
There are products out for that case. So if you want to do that, so they are also laying on different network layers to do reducing the traffic and see anomalies in your network. So I know at least one through Neuvector, they're using it. They're using also more kernel technology. So they're a little bit independent from the stuff if you're using Velcro, that's based mostly on eBPF. Or using other tools like Aqua Security has also some tools, but I don't know it. But that's for secure network traffic on demand. Yeah, so that you automatically can see, or it's also possible with Cilium. You can also do that.
Yeah, it often depends where your cluster is running and so on. So how your setup should be. If it's a cloud managed cluster, if it's Google Autopilot, if it's kubeadm or Rancher, you have to see what you are running and then check the solutions, I think. I mean, but we're on a good status now. You could definitely do more always. You could always do more for security. You could harden your nodes, like they proposed here, restrict API access, restrict network access to nodes. So this is really good. Basically, a basic security guideline here. And then basically you kicks in the admission controllers. There are a lot. So you can program your own admission controller. You can validate. You can generate requests. So everything is possible. You see the possibilities here. This is the list. Deny resource quota. We did not touch resource quotas. So there's also something. Yeah, there's a lot of things you can do. Policy report. There's also on Kyverno. He has two good blog posts. It's the validation part here, exploring Kyverno, and then you have the mutation part. It's also part 3 about generating things. So it's a cool series here to understand a little bit what they are doing.
Link them?
Yes, I will share it for sure. Yep. Okay. What else? I don't know.
No, I think.
Yeah, then you can also use Kubebench, for example. This is like also we discussed last week. This is a sys tool to check the worker node, check the control plane for basic sys security, sys recommendations. There's a lot.
I think I was touching too many topics in my thought, but I was probably thinking of trying out kube state metrics and touching with Prometheus and Grafana, and also use that for like combining it later on. So probably one of the next things which would be interesting would be either monitoring or like diving more into the security layer. What else? Automating things. Yep. I'm totally up for what you want to do. So just the first one who says I'm preparing something for next week wins, as always.
I think we should, if Niklas has time, we should dig into his OpenID thing, because the authentication, oh my God, authentication and authorization parts is also really interesting for me. So if he has time and can finish the OpenID thing, it would be cool. If not, I don't know. We can automate what Max and I did. So I can add Kyverno policies to the cluster repository of Max, for example. I don't know if he wants it, and then we can automate the whole stuff with Terraform and Max GitLab CI code. From my point of view. Sorry, Niklas, I interrupted you.
Yeah, no problem. Yeah, we can do at least the OpenID stuff next week. So, but I think it will take only 30 minutes mostly, 20 under 30, to do that. And then probably I could also give a short introduction about how to monitor stuff on Kubernetes. So that we setting up the stack, like I won't go with kube-step metrics. We will see, probably we're using Prometheus adapter there, and probably deploying the Prometheus operator. Or it's not called Prometheus kube stack, something like that. I don't know the name by my hand. And then we can see at least some metrics on the cluster that we created. And probably then we can combine a little bit more in terms of that we probably then also integrate Kyverno then, or having a more policy framework for that. So probably I can go into a little similar topic. So because I think, was it Kyverno or was it another tool? Let me check. This is a policy agent. No, I'm looking
for
another
open policy agent. You need the gatekeeper, I think, but gatekeeper is not. Let's say.
For...
No.
Second.
I mean, it depends. It depends what you want. If you want sophisticated things,
I'm looking for kiosk. This
kiosk,
was
okay.
the tool. No.
So if we want to keep security and an OpenID and everything around it, wrapping it up next week would be a cool thing. Because for monitoring, I think we will take at least 1 hour. And if it's in 2 weeks' time, I'm probably more relaxed with preparing something. And we could like take the whole hour and diving into monitoring observability and doing some more live hacking sessions. Next week we can, if you're up to it, OpenID and
user management, a little bit more advanced case. So probably, I can probably shortly share my screen. Give me 1 second. Or someone can open the link. If Philip can open the link, it would be really cool.
You posted in chat?
Yeah, in the chat. Yeah.
Other kiosk.
So, yeah.
Is mine. Okay, wait.
I
have to get used to. My window is lost here. Where is it? There. Okay.
Oh, you have dark mode. Probably then the image is not so good. Going down a little bit. Going down. Yeah, blah blah. Yeah, probably when you now open this new page and set in the background to white, it's probably readable. Otherwise, I can also
wait, I have to.
No, let me hijack the session.
I can just. Wait, wasn't there? To go my profile, I think. Here.
Just use DevTools.
Also, it was hijacked. Going down to the image.
He's on my PC.
Yeah,
How you did it?
I'm the host.
He's a magician. Besides that, so yeah, literally.
Magic.
Probably then we have users, but then we have also a little bit more problem of account management, which user can go in and so on. And Kiosk is more tool when you want to manage multiple users on your clusters. And also what is more interesting if you're seeing also accounting, for example, that you can create templates or spaces. They have an abstraction stored space where you can dynamically create pre-templated namespaces for your apps and so on. So this is a more high-level management solution for really having a multi-tenancy in your cluster. You need to know that Kubernetes is not hard multi-tenant. It's not possible to do hard tenancy in Kubernetes, but you can do at least a soft tenancy. So for that, we could also look into Kiosk, where we can then create a more tenant-based Kubernetes cluster where we can share multiple groups in one cluster and so on. Yeah.
I like that. I buy it. Where need to I put the Rashikiksi in?
Probably you need to send it to another location. We will need to check. Probably because I'm also moving again. But yeah, I can talk later.
Okay, then let's wrap up and say we're gonna look into OpenID and Kiosk for multi-tenancy management next week. And in 2 weeks' time, we do a stop in monitoring maybe debugging, monitoring, breaking something again. Yep, and I would love to say thanks to Philip for preparing today's session, making it really insightful, and learned a lot today. Still need to practice it, and I encourage everyone listening now or watching now to just go ahead and try this out. We will share the blog post later on. Yeah, and thanks for watching, and see you next week. Bye on YouTube.
Bye.